8.5, annuities, methods of savings and investments. Now is very much the time where we're going to start seeing almost every formula show up on the mortgage project. So I would take extra care in this section to take down notes, kind of put stars next to these formulas so that when it shows up on the project, you can just flip back through your notes and be like, oh, okay, you wanted me to find this. I have the formula for that, and I am good to go. Now, annuities. Reason why we see annuities, especially with house buying or car loans or stuff like that, is generally when you're taking out these loans, you are expected to pay a certain amount every month. They're not going to say, oh, okay, just like, pay whenever you want to. We'll just get around to it whenever. It's always when you kind of figure out these house loans or car loans, they say this is the very minimum that you have to give us per month. And so with that in mind, we are going to use interest formulas, but we have to be a little bit careful to kind of almost adjust for the fact that you are going to be paying a regular amount. So in this case, we have another savings example, because I think that's just the easiest way to tie these concepts down. And we say in the savings account, we deposit $1,000 every year at the end of every year for the first 3 years. What will be the value of the account if it is compounded annually with a rate of 8%? So this is almost the exact same question that we saw in the previous two sections. It's just now, instead of just putting in the money and saying, oh, I'm going to wait and see what it looks like in 3 years, we're going to start putting in more money because maybe we're able to save more frequently. And so here I have EOY, that's an abbreviation for end of year. So I didn't put anything in my account until the end of my first year, and then I'm going to put in $1,000. So that's how much is there at the end of the first year. Now, at the end of the second year, I'm going to compute the interest that I earned on my initial investment, and then I'm going to add $1,000 to that because I'm going to deposit more. So if we're using the compound interest formula, my rate is 0.08%. My time is 1, my n is 1, and that's how I have this very simplified version of 1 plus 0.08, and that's it. If you looked at the formula and you filled out everything, that's what it simplifies to. And so 1 plus 0.08 times 1,000 gets me 1080, plus 1,000 means that at the end of year 2, I have $2,080 in my account. And now we repeat. Now I'm going to calculate the interest on my lump sum that I have of 2,080. Again, rate's 0.08, time is 1, times compounded is 1. And then I'm going to add another 1,000 at the end of the year. So I get 2080 times 1 plus 0.08. Make sure you're following your order of operations. Gets me 2,246.40. I add the 1,000 that I would be putting in at the end of the year, and now my account has 3,246.40. And this is also something you see with retirement a lot, and that's why a lot of people love to do this with a retirement. Is it doesn't seem like it's a lot when you're kind of putting in a little bit each year, but it starts compounding, gets bigger, and then you're adding more interest each year. So that's that's why a lot of people like to start saving early, because then you get a huge, well, depends. You get a relatively huge sum once you retire. Now, the annuities formula, we can, instead of going through that process every time, because sure, we did 3 years, that's not super difficult. We could go through that whole process. There is a reason why I kind of sprinted through that slide. And it's because there's a formula that does all of that for us very nicely. And this is a formula, if I remember correctly, that we will be using on our mortgage project. So I would, in your notes, put stars next to this. And so I have my A is equal to, and all of these things in this formula we've seen before, just not in this order. P is my principal, R is my rate, T is my time. So I'm going to deposit $1,000 into a savings account at the end of every year for the first 3 years. What will be the value of the account if it is compounded annually at a rate of 8%? Well, pretty much what we've seen in all of these sections is when we have one of these scary formula problems, it's really just plugging in values and then making sure I put it into my calculator correctly. So I have my P is 1,000, my rate is 8%, so 0.08, and my time is 3 years. So I throw all of that in, and I find that once I calculate that, I get 3,246.40, which should be the same thing I got in the previous example. Yes, cool, good, that's good news. Now, just like when we saw the original compound interest formula, there is a better compound interest formula. And that is this. Now, instead of assuming we're always going to compound once a year, maybe we'll want to compound our interest monthly or weekly or daily or something like that. And so we would use this formula, which, if we plug in 1 for n, simplifies the formula we saw in the previous slide. Again, I would star this formula. This is a valuable formula to have in your back pocket. So now we have a problem that at age 25, you just decide to deposit $200 at the end of each month into an IRA that pays 7.5 compounded monthly. How much will be in your account when you turn 65? So IRA is a fairly common investment method, especially if you're not making an exorbitant amount of money. It's very nice because you don't get taxed as much up front as opposed to later. And that's all on a side. Anyways, you're just investing it into a retirement fund. You put in 200, so that's your principal. Your interest rate is 7.5%, so 0.075, and you are compounded monthly, and is 12. And how much will be in your account when you turn 65? So you started doing this depositing at age 25. When you turn 65, well, 40 years have passed, so your T is 40. So that is where all of those things go into the formula. Again, we have to very, very, very carefully put it into our calculator, make sure we're not messing up the powers or the brackets or anything like that. But at the end of 40 years, we have $604,765. 7.5, again, is a little bit of a generous amount, but I mean, even if this was 2.5%, you're going to have a lot in your account. So all this is to say that if you have money, which not a lot of us do, me included, but if you have money, it's a really good idea to start your retirement fund early, because even if you're putting away $200, which, I mean, seems pretty doable for most people, some people, but even if you're investing that much or that little amount of money every year, well, once you do it after 40 years and you've been doing it in a IRA that has a really good interest rate, then you will have a lot of money by the time, well, you know, a lot of money when you retire, maybe not enough to live the rest of your life, but, you know, hopefully you've been saving on other things as well. Okay, so regular payments to achieve a financial goal. So this formula is super cool because sometimes when we save, if we're like tucking something away in a money drawer, we don't really have to do a lot of difficult work to figure out how long we will have to save to get a certain amount. But when we start dealing with interest rates and being able to invest or being able to put money into a savings account, things get a little bit more complicated. So what this formula tells you is it says, okay, you can give me your desired amount. No. So this formula is super helpful and super interesting because, yeah, sometimes when we're saving for something and let's say we're just tucking our money away in a coffee can or something like that, well, it's not going to be super difficult if you have a regular amount that you're like saving up to figure out, well, okay, how long will I have to do this in order to save the desired amount? It becomes a little bit more tricky when we have things we can invest in, or have a bank account, a savings account, even a retirement fund, something like that. And so what's cool about this formula is you can start with, okay, what is my future value? I want to earn $20,000 to save a house or a car or something. Save a house, buy a house, or buy a car. What do I have to do if I have this account in order to make that happen? What's the amount that I have to continue depositing? So that's what this formula does. It's almost kind of magical that it churns out and says, okay, here's the amount, save $50 in your account, and you will have that desired goal if you continue to do this for X amount of time. So to see it in practice, suppose that you want to buy a house and you would like to save $20,000 over 5 years. Well, you might be thinking $20,000 is not going to buy you a house. Yeah, for almost 98% of houses, that's true. You're not going to buy a house for $20,000, but that is a pretty good down payment. We'll talk about how down payments work and what's a good one and what's a bad one when we're working through the project. So that's where this comes from, is